Most Blender tutorials start like this. You open up a scene and you delete the default cube. But if you don't know Blender's underlying data structure, you don't really know what you actually just did. Most people use the outliner window in view layer display mode, but our really useful display mode is Blender file. You can see our objects in scene are the camera and the light because we deleted the default cube, but under meshes, we still have a cube. It's just not being linked to an object that exists in the scene right now. We can also see this little icon next to the cube telling us that there are 0 users and this item will be removed. That means when we save and close Blender and we reopen this scene, Blender will get rid of this cube mesh. It'll be purged. However, today we're bringing back the default cube. Blender's built off a system of Datablocks. It's accessible through Blender's Python API and what is called the Data API. And there's actually a view mode for this too. This is kind of a tree of the Data API. This is all of the data that exists in this current blend file. Inside of the Data API, you can see things like objects, our camera and our light that are in the scene. So under meshes in the Data API, we still have the cube. So if we want to give this cube mesh a user, we can do that with Python. We're importing BPY, which is Blender's Python API, and then we're going to access this cube mesh. So inside of the Data API, bpy.data, we're looking for a mesh in meshes named cube. What we want is a new object in the Data API named cube that holds this mesh as its data. So we can do this by calling bpy.data.objects.new, and now it needs a name, so we'll name it cube, and then it needs data. It needs this as the data, so we can assign this to a variable. I'll call this mesh. What we're doing here is we're adding a new object to bpy.data named cube with the data of mesh, our default cube. We can run this and it's added. Now we can see in the Data API view that this cube is an object and it contains data of the mesh named cube, but it didn't get added to our scene. That's because the scene itself is a data block. We can see this if we drop down scenes here. Our scene is named scene and it has a list of objects. Right now it's the light and the camera. What we really want is that cube object that we just added. We want to add it into here. So we don't need to make a new object anymore. We'll just say object equals bpy.data.objects, and we'll grab a specific object, our object named cube. We need a reference for the scene. So I'll say scene is bpy.data.scenes and get an explicit reference to the scene. So this scene variable represents exactly the data in the Blender file named scene. It doesn't matter what scene I'm in when I run this script. We need to add this object into the scene now. You might think it's scene.add, like how we created the object, but really we're not adding anything. We're creating a new link between data blocks. So the way we do this is in the scene's root collection, it has a list of objects in which we want to link object, this variable, our data of the cube object. So when I run this script, you'll see that the cube was added back into our scene. Now we have the default cube again. You might not know this about Blender and the Data API, but you've definitely felt it. if I delete this cube again and I add a new cube and I switch back to regular view layer mode, you would see that its mesh is cube.001. And if I add a new material, this material is named material.001. That's because that material and that cube mesh still exist, even though they were deleted, because you only deleted the object data block. So let's undo back to the point where I have the cube added into the scene collection. It has its mesh of cube, and it has its default material. Now, what happens when I try to run this script a second time? It's going to grab the object cube from bpy.data. It's referencing the current scene, and it's going to link that object into the scene. So what happens here? Does it create a duplicate of this object? Does it create a duplicate of this mesh? Let's just run it and find out. You'll see you get an error. Cube, the object, already exists in the context of this scene in the collection scene collection. But if we modify our script and do something more similar to what our original call was, where we did objects.new cube with the data of mesh. And let's write this line again where we had mesh equals bpy.data.meshes cube. I'm telling the script we're going to add a new cube as object and link it to the scene. So it looks very similar to the call that failed, but when I run this, you'll see a new cube object. I'll move it over to the side so you can see, is added to the scene, and its name is incremented because we told Blender we want a new object and we want that object named cube. And Blender says, okay, I'll add that object, but you already have an object named cube, so I'll increment the number. However, when we ran this call, we still used mesh, our bpy.data.meshes cube, to create this object. So something interesting happens in edit mode when I move around vertices of either one of these. The other one mirrors it. That's because these are just pointers to the same underlying mesh data block. And you can see this really clearly in the Blender file view mode. We have our unique objects, cube and cube.001. They each have one user, which is the scene as its user. And they each reference cube, the mesh, as their data. Now, objects are an interesting type of data block because they take the form of their data. And this is a semantically confusing aspect of Blender because bpy.data.objects cube.data is literally the same thing as bpy.data.meshes cube. And I can prove this to you by just making this print a Boolean. It'll say true if this is in fact true. So let's look at our console. And you can see that is in fact true. I say this is confusing semantically because Blender could have called this something more like payload, but this is just the way it is and the way it has been for a very long time. This is made pretty clear in the Blender interface. If you look in the properties window for either one of these objects, you'll notice this tab is actually called the data tab. And this is showing us the data of the mesh that's being used. You can see this is the cube mesh. Like if I rename this here to my cube, you'll see under meshes, it changes my cube. It doesn't change the object's name. And you notice that my cube here has two users. That's what this two means. Two separate data blocks are referencing this data. Now if I click this button, it makes a copy of that mesh data, and it makes that data unique to this object. So now when I edit the vertice, it doesn't change in the other object. So I'm going to undo that for now. So again, now we only have one cube mesh, my cube, that's being referenced by both of these. All of the attributes listed here relate directly to the mesh. But there's some other things that relate to the mesh that you might not realize. Materials, for instance. Obviously, if I change the color of the material, or both these objects have the same material assigned, so when I change the color, they both change. But you might not realize when I delete this material, I add a new material, they still are connected because material is a property of the mesh data. And this isn't very clear in this interface, but it is very clear in the data API. If I unfold objects here and we look at cube, you can see it has data, which is the mesh, my cube. And if we expand this, we'll see all of the properties related to my cube, as well as materials, a material list. So certain attributes about your object exist as mesh data, and certain attributes exist as object data. So things like its position in scene is obviously independent between these two objects. Something a little more hidden that's part of the object's data layer is modifiers. If I add a subdivision surface modifier, you can see it only affects one of these, even though the mesh is the same in both of these objects. So in edit mode, when I'm moving vertices around, both these act identically, but the modifier stack can be individual per object. So let's take another look back at the Blender file. You can see I have cube and cube.01, each is being used by the scene, and we know that my cube is being used by both of those cubes. Now, can an object have multiple users? I told you earlier that scenes are also data blocks, and scenes have their own set of properties, one of which is where we added the object into the scene's collection of objects. So if I make a new blank scene and I reference the cube from object data, and I get a reference to the new scene, scene.01, I can link this object into the scene. When I run this, you'll see this cube with the subdivision surface modifier is added to this scene. So that means I linked this object into the new scene, and its object properties also persisted in the new scene. And now you can see that this cube has two users, which are each of the scenes. So when I take this cube and I move it in one scene, its movement is reflected in the other scene because all of the object properties are linked. Also, when I edit the mesh in the second scene, return to the original, you'll see this object is modified, this object is modified, and it works from any of them because they're referencing that same underlying data. So back in my new scene again, if I go ahead and I increase the subdivision and I say apply smoothing, and then I go back to the original scene, you'll see that smoothing did apply to the original object and the subdivided object. That means that smoothing is actually a property of the mesh, which makes a lot of sense if you think about vertices and edges being smoothed. Now, where do you run into this the most, and why should you know this information? What trouble can you run into because of the way that this data system works? A really common one is So say you spend a lot of time on some kind of shader, and maybe you even have a node group in this shader to change some aspect about it. Maybe name this node group something, and you have it on this object. But you decide, I don't like this object, I don't like this mesh. I'm going to assign this to a sphere. So you delete the object, you add your sphere, and you select your material. But where you can get into trouble with this is, say you delete the object, but then you save, close, and reopen your Blender file. That would be akin to doing this purge unused data. Now I add a new object, and I look for materials, and nothing's here. All my work was lost. If a data block isn't being used by anything else, Blender considers that pending garbage or an orphan and deletes it on save, close, and reopen, or if you purge your data. It's just Blender's way of keeping your file clean. But it can result in scenarios like this where I spent time on something, I expected it to exist in my project. I only deleted an object, I didn't delete that material. But since I deleted all of the users of that material no longer exists, and that node group I made inside of that material no longer exists either. Now, the way that you can mitigate this is this little shield button. It means fake user, and it isn't saying that I'm making this node group a fake user. The correct way to say this would be pretend this node group has a user, a fake user, which is the Blender file itself. So you're telling Blender, yes, I'm using this node group. So now if I go ahead and delete this object, purge all unused data, add another object, look for a material. I still don't have any material, but if I add a new material, I can look in my node groups and I still have my ramp position node group because I set its use fake user property to be true. Another way that you can see this is, again, in the Blender file view mode of your outliner. You can look under materials and you can see this material, and you see the use fake user button. It says it's currently being used by one object, this object. If I turn this materials use fake user property to true, also you'll see that number ticks up to 2 because use fake user actually increments the user count by 1 no matter what, so that if there are 0 users, there's still 1 user technically. Just like the mesh, if we had multiple of these and we really like this ramp position node group, but maybe this one's metallic and this one's not, we can click that make single user button and you can see this incremented the material's name. It kept the same ramp position node, but now I can change the metallic property of this one separately from this. And now you see in the ramp position node that this has 2 users. So if I change the value of the ramp position, only one of them is going to change because this node itself belongs to the material, but what's inside of the node belongs to the node itself, the data block of the node group. So if I change the way that this operates, you can see it very slightly in here. Maybe I'll alter this one too. So if I change this color ramp, you can see both of them being altered at the same time. If I change this value, you only see this material's value changing. And if I wanted to handle the color ramp differently in this object, I can always click the Make Single User button. And then now I can go in and I can edit this color ramp without affecting the other one. Another area that might frequently trip people up is the image editor. Say you load some kind of image for reference, but you don't assign it into any material. You just have this image loaded into an image viewer. You can see in the Blender file display mode that this image is now loaded into bpy.data.images. Okay, let's add a second image into here. So now I have two images loaded into Blender, and we know that if we save, we close, and we reopen, we'll still have those images, right? If I switch which one I'm viewing, I save, I close, I reopen, these images still exist again. But you notice that the one that I'm not currently viewing is listed as having no users. Well, why did this happen? When you load an image into the image editor and you don't assign it anywhere else, the image editor is what we call a soft user of this data block. It uses this data block, but it uses it temporarily. If you want to be sure that the image that you loaded into the image editor will continue to exist as you edit your file, as you purge data from your file, as you reopen that file, maybe save it in a different place and reopen again, you want to be sure to use the use fake user true button for that image. That way you're guaranteeing that this image will persist no matter if you have the image editor open or not. In any context, this will exist. You don't need to worry about that if your image is loaded into a material, because this will give that image a user. You can see it removed it immediately from our orphan data list. My other image, that image of the outline of a cube, is marked as having no users right now. So if I save, I close, and I reopen, you'll see there's no images listed under unused data. So it's gone. With geometry nodes getting more popular, this is another aspect to look out for. You can see that geometry nodes themselves are a type of node group that are a data block. And they can have a fake user. In the same way that you might spend a lot of time editing a material, you might spend a long time on some geometry nodes, and say you do something crazy, you don't have fake user set, and you apply these nodes, and then you add another plane and you want to add that same geometry node modifier. You can see it's listed here because I didn't save, close, and reopen. I didn't purge my data, so I can assign that node group again. The tricky part comes in when you apply a node group, you're happy with your result, you save, you close, you reopen the file, you go to add a geometry nodes modifier, and you don't have any data anymore, and your work was lost again. Obviously, you can dive as deep as you want into the Blender Data API. A lot of tools are made by scripting through the Data API almost exclusively without using operators, but it also just helps you understand how Blender works. Now, we've been talking about object data as in meshes most of this tutorial, but I want to make the clear distinction that objects are not exclusively mesh based. If you have a light in scene, You can see under lights, now we have our point light, but under objects, now we have the object called point, which is also the light. You can see this in the regular view layer. When you expand point, you see point. This is an object. This sub-object is a light or light data. And you can again see this in context when you look where mesh data was when we selected an object that had data of a mesh called the data tab in properties. When you select a point object and you're in its data tab, you'll see data related to a light. Everything I explained about meshes also pertains to lights, cameras, curves, any other object that can exist in scene. These are all object subtypes. And the type of data that an object contains determines the type of the container. This can be really confusing, but all you really need to know is when I click this drop down to select which light I want to use, this is grabbing a list from bpy.data.lights, whereas this is grabbing a list from bpy.data.meshes. I can't just arbitrarily grab a point light and turn it into a mesh. So now that you have a baseline understanding of the data API, we can open up a new blank project. You can select all and delete. And now we can purge unused data. You can understand that we deleted in scene the objects that represented the camera, the light, and the cube, and now the orphan data blocks that resulted from that. If we uncheck recursive delete, you'll see that the material does not exist here anymore. It won't be purged. That material would persist if we don't do a recursive delete. Anything only with specifically 0 users will be deleted, and its data will then just be orphaned. So when I run this without recursive delete, and we look in our unused data, we will see material of 0 users added to this. So because now the mesh doesn't exist, when we clean up purge unused data without a recursive delete, that material is now listed because it has 0 users. Before it had 1 user, that user had 0 users, that user was deleted. Recursive delete handles this for as many nested layers as exist. So if I open up a new file again, I select everything, delete it, I go to clean up, purge unused data, I use a recursive delete. I know that those 4 data blocks were the cube's mesh, the light's data, the camera's data, and the cube's material. And now I can go to File, Defaults, Save Startup File, Overwrite, and we never need to worry about the default cube again.